Alrighty, so today we are going to talk about the solubility equilibrium and what that means. What does it mean for a salt to dissolve? We also call this process dissociation. When an ionic compound, otherwise known as a salt, dissolves, they begin to dissociate or separate into their separate base ions. Remember that an ionic compound is composed of two ions, a metal, which is a positive ion, and a nonmetal, which is a negative ion. The ions have a transfer of electron, which causes them to become an ionic compound. If we look at the examples that we have here, you can see that we have silver chloride, which is a solid in this case, and it has a reversible reaction. So it's going back and forth, making products and reactants into the silver ion, which is Ag+. And you see that it's aqueous. That should tell you that it's in what? In water. Good job. Plus chlorine, Cl negative, which is also aqueous. Remember that you can find the charge for the ions by looking at the periodic table at what group they're on. The other example we have here is magnesium chloride, which is a solid. You add the water and it goes back and forth into magnesium 2+ aqueous plus Cl negative aqueous. You see that we have two chlorines here, and you have to do that because that means that this equation is now balanced, because we have two chlorines on this side means we need to have two chlorines on this side. So here's two examples of ionic salts that are dissociated into their separate ions. You should not only be able to look at these, but you should also be able to write these type of equations and what they look like. Okay, so hopefully you know that not everything is soluble in water. And because we're talking about equilibrium, you probably know that sometimes when you put an ionic compound into a water, it doesn't completely dissociate. Maybe it dissociates 50%, maybe it dissociates 2%, maybe it dissociates 98%. But the way that we tell if something is soluble or non-soluble is we use a list of rules. Now, you're not expected to memorize these rules, but you are expected to be able to read them. So we need to be able to look at a salt, and then we'll look at the rules, and you need to be able to tell me, is it soluble? So does it dissolve or dissociate into ions? Or is it insoluble? Will it stay a solid? And another time that we see this is when we have a double replacement reaction. A lot of times in a double replacement reactions, one of the new products will remain soluble, and the other new product will become a precipitate or salt out or be insoluble. And you need to be able to use this chart to be able to answer those questions. So looking at the chart, you start here with your soluble ionic compounds. And you see that on the left side, we have 4 groups of soluble ionic compounds. Group 1A ions, remembering that if you're looking at your periodic table, the far left is group 1, the row that goes up and down, are all soluble ions, including ammonium, which is an NH4 positive ion. That is the only polyatomic ion that you had to learn that was positive. It is soluble. Number 2, nitrates. That is another polyatomic ion that you were supposed to know, NO3. Acetates and most perchlorates, or ClO4, are soluble. Number 3, chlorine, bromine, and iodine are soluble, except when they're paired with silver, lead, copper, and mercury. Like I said, you don't have to be able to memorize this, but you do have to be able to look at the chart and read it. So if you have something that says, for example, magnesium chloride, you would look at number 3 and you say, okay, chlorine is soluble, except when it's paired with silver, lead, copper, or mercury. Well, is it paired with one of those? No, it's paired with magnesium. So that would tell you that it is soluble. So if you had magnesium chloride, it would be soluble. But if you had, for example, silver chloride, it would be insoluble because that's what your chart tells you. Okay, so look at number 4. That is sulfates. Hopefully by now you know that sulfate is SO4. These are all soluble except those with calcium, strontium, barium, silver, and lead. All right, so that's where we're going to start with the solubility on the left side. On the right-hand side, we have insoluble ionic compounds. So if you have a hydroxide, once again, one of our pesky polyatomics, that is an insoluble compound except when it is paired with group 1 ions, lithium, sodium, potassium, etc., the ammonium ion, and calcium, strontium, and barium. Sulfides are also insoluble with the exception of being paired with these groups. Other insoluble ionic compounds are carbonates, another polyatomic, CO3, 2-, and phosphates, PO4, 3-, except when they're also with our group 1 ions and ammonium. Okay, so hopefully you are able to read your chart. Okay, the other way that you might possibly find solubility, instead of looking at the list of solubility rules, is you may be given a solubility table. And this solubility table is formed with common ionic compounds. The way you read this table is you look at the cation. Cations are the positive ions, and the anions, the negative ions, and you find where they meet to see if you have something that is soluble or insoluble. So let's pick aluminum. Let's say that you have aluminum sulfate. So you would have aluminum, you would go down and you would find where it meets with sulfate right here. SO4 is right here. And SOL, that tells you that that is soluble. Anything that is green is soluble at greater than 1 gram per 100 milliliters. SOL means slightly soluble. That is 0.1 to 1 gram per 100 milliliters. And insoluble means there is less than 0.1 gram per 100 milliliters. If it is blank, that means there's not enough data to be able to tell the answer to that question. Okay, so the solubility product constant is derived the same way that we derive the solubility, the same way that we derive the constant of at equilibrium. So the constant of the solubility product, so the constant of EQ is the constant of equilibrium. The constant of the solubility product is the K of SP. So this is the constant of equilibrium. The K of SP is the constant of the solubility product. Now, hopefully, by now, you guys know which side is the products and which side is the reactants. This is your product side. This is the reactant side. So if you look at the equilibrium constant, you know that we write it by the concentration of the products. So the Cl minus squared, because it has a coefficient of 2, times the concentration of the magnesium 2 plus over the concentration of the magnesium chloride on the bottom, because these are our reactants. This is for the equilibrium constant. The solubility product constant, we are only looking at the products, which makes sense because it's the constant of the solubility product. It's the exact same thing as what is on the top of the constant for the equilibrium, except you just do not have the reactants on the bottom. So you look on this side, on your product side, and you multiply the concentrations times each other to the power of their coefficient, just like we did for the equilibrium constant. Now, what you guys are going to do is go to Schoology, and there is a sheet that you have to balance the chemical equation, then you have to write the constant for the equilibrium, then you have to write the constant for the solubility product. I know that maybe seems redundant, but we need to practice and make sure that you guys got this before we move on. All right, have a great day, and I look forward to seeing you tomorrow. Bye.